AQR, Advanced Quantitative Reasoning. We are going to be exploring more estimation of large numbers today. So our learning goals are using proportions and the fundamental counting principle to estimate large numbers, and simplifying assumptions about real-world situations in order to solve hypothetical math problems. So similar to our estimating large crowds, but today we're going to be looking more at different combinations. And no chapters because there's no textbook accompaniment to this course. So the first thing I would like you all to do is to think about how many uniform combinations you have available to yourself. If you have 3 polo shirts and 3 pairs of pants, so you have 3 polo shirts and 3 pairs of pants. How many uniform combinations do you have? Hopefully by now you answered. You could have drawn them out, right? If I drew them out, it might take a while. I have 1. Let's just do a different color here. A green polo shirt. What a nice shirt. And a blue polo shirt. And then we have 3 pairs of pants. We can keep those all the same color. 1, 2, 3. So when you draw a picture, it's nice because then you'll say, okay, I can put this red shirt with this one, and this one. And then I'm going to change up the color. In fact, let me go ahead and do it this way so it makes more sense. Let's do it the same color of our shirt. So I have this combo, and this combo. I also have this combo, and this combo. And lastly, I have this combo with this pair of pants and these pair of pants. So from the blue, I have 3 combos total. From the green, I have 3 combos total. And from the red, I have 3 combos total. So hopefully you got 9 uniform combinations. Okay, so that's going to lead us into our lesson today. And so now I want us to just talk about what really is this warm-up about. And that's what's called combinations. So when we are talking about ordering of groups, of lists, right, of a variety of things, we can have a combination or we can have a permutation in order to figure out how many different pairings there are, essentially. Okay, so combinations, the order doesn't matter, right? So let's say for my last example, I put my red shirt with the last pair of pants and then my red shirt with the first pair of pants written. The order doesn't matter, right? Those are just each unique combinations, but it doesn't matter if I put the first pair of pants on and then the last pair of pants. Each one is still just one combination. So let's dive into that some more and the different ways that we can, I guess, express our combinations or really figure out our combinations. So let's say you are trying to figure out the food you want for today. Food for today. You're going to start with a coffee. And then and then go to, and then go to your fave lunch spot. So for your coffee options, you are either going to go to Starbucks or you're going to go to Dunkin'. And then for lunch, you're either going to go to Chick-fil-A, you can go to Raising Cane's, or you can go to McDonald's. So we're trying to figure out then how many different food combos or options do we have today? I'm weary to say options because you may be inclined to say, oh, well, I have 1, 2, 3, 4, 5 different options of food, but we're specifically thinking about my combination options. Do we have today? So the first way we can do it, I'm going to write number 1, is just write out the combos, just like I did for our warm-up. Write out our combos. So I can have Starbucks with Chick-fil-A, Starbucks with Raising Cane, and I can have Starbucks with McDonald's. Or I can have Dunkin' with Chick-fil-A, Dunkin' with Raising Canes, or Dunkin' with McDonald's, which gets me 6 combos. Okay, excellent. So now let's look at our second way, which is drawing a tree diagram. Oops. So we'll say, okay, my first option to choose from is coffee, and my second one is my lunch spot. So for my coffee, I have Starbucks. Let me do it this way. Put those in red since they're not our actual options, so we don't get confused. I have Starbucks and I have Dunkin'. And then I'm going to branch off. I'm going to say, okay, just like we did before, written out, I said for Starbucks I can go to Raising Cane's, Chick-fil-A, or McDonald's. And then I can go again, Raising Cane's, Chick-fil-A, McDonald's. And then however many you have left, however many branches you're left with, number of branches at the end equals your total number of combos. So that's how I get, again, 6 combos. Excellent. And 3, which is the most important one, and the one that's going to make our life easier, is the fundamental counting principle. Before I give out the definition or explanation for what that is, let's think about how 6 relates to our options. So my coffee, I have 2 options, and my lunch spots, I have 3 options. And how is 3 and 2? How can I relate 3 and 2 to get 6? If you thought, oh, well, 3 times 2 is 6, you're exactly right. You are going to multiply the options to get total outcome. Total number of outcomes. So indeed we had 2 coffees times 3 lunch spots, which equals 6 combos. In fact, just because I really hate using this word option, I'd rather us just say outcomes. Because options are kind of singular. Outcomes, that encompasses all of our combos. Okay. Permutations, on the other hand, our order does matter. And so let me just give you an example here, because we're not going to be using permutations today, but I want to give you an example of what a permutation is. So let's say I have a student government election where we can have a president, a vice president, and a secretary. Okay. Well, the people I have running are, let's see. Let's just do 6 of the names that come fastest to me. So we'll say Sam, Carla, Rick, Danny, Sarah, and Garrett. Okay, so all of these people are running for president, vice president, and secretary. But now you all have to tell me, or I guess hopefully agree with me. Would we agree that if in my president spot, if I have Carla, Danny, and Garrett versus Danny, Garrett, Carla, we have those same names, but these are two totally different outcomes. So essentially, that's why order matters. Order matters here. So that's why sometimes people say, you know, when you have a lock for your locker, lock for locker, and they're like, what's your combination? Well, really, they should ask, what's your permutation? Should be, what's your permutation? Because essentially that would be like, oh, if I gave you 3, 4, 5, well, the person could order it like 4, 5, 3, right? And technically, if they said combination, it would be the same, but we know that that would give, one would let us in and one would not. So that brings us into our, the meat of our material today. And today we're going to be talking about telephone numbers. So during the past few years, there have been several statements of the form, it is conceivable that we may run out of area codes and telephone numbers within the next 10 years. The shortage of phone numbers is due to the proliferating use of cell phones, pagers, and fax machines. In the next few problems, you will estimate the number of possible telephone numbers in North America. The assignment of telephone numbers is coordinated by the North American Numbering Plan Administration. If you're interested, go ahead and visit www.nanpa.com. NANPA actually covers only the United States and its territories, Canada, and the Caribbean. Mexico is not included. A telephone number in the form NYZ ABC-XXX has three sections, where NYZ is the area code, ABC is the exchange code, and XXX is the station code. Before 1995, all area codes had the form NYZ, where N was any digit from 2 to 9, Y was 0 or 1, and Z was 1 to 9. If Y was 0 or Z was 2 to 9, if Y was 0, okay. So Y was 0 or 1, and Z was 1 to 9 if Y was 0, or Z was 2 to 9 if Y was 1. That's more like it. That was a little bit worded weirdly. The restrictions on N saved 0 for call operator and 1 for long distance calls. In addition, codes such as 800 or 911 were and still are used for special purposes. The restriction that Y equals 0 or 1 was removed in 1995 because all possible area codes had been assigned. Today, N is 2 to 9, Y is 0 to 8, and Z is 0 to 9. The exception to these rules are the codes of the form 37Z and 96Z, which are being reserved for future use. Area codes where Y equals Z are called easily recognizable codes and are often assigned to special services such as 800 and 877. So interesting stuff here. And this makes sense, right? Because for the U.S. territories, Canada, and Caribbean, because we use the +1 at the front of ours. Like if you go and leave the country and you're trying to call back to America, you have to dial +1 before you dial the phone number. So this is before 1995. We had N from 2 to 9, Y was 0 or 1, and then Z was 1 to 9 only if Y was 0, and Z was 2 to 9 if Y was 1. Okay, excellent. And then in 1995, 001 was removed, and now we could use 0 to 8 for Y. Interesting. So my first question to you all is, how many area codes were possible before 1995? Okay, so we're going to use the fundamental counting principle here. And in order to solve this, we need to first think about, well, what is an area code? Okay, well, I know my area code is NYZ. So that's what I'm going to first start off with. I know I have N, Y, and Z. So I'm looking for those combinations. Before 1995, okay, so N was a digit 2 to 9. So 9 minus 2 is 7, and then we add 1 to include my first number. So that's a big thing I think we forget. So when we're trying to figure out the total numbers between something, we have to remember that we're including the first and the last number. So 9 minus 2 gets me 7, but I need to add 1 so that 2 is included. So that's going to give me 8. So I have 8 options for N. 8 options for N. Okay, and then Y was 0 or 1. Okay, so if Y was 0, let's start with that one. If Y was 0, Z was 2 to 9. No. Z was 1 to 9 if Y was 0. Z was 1 through 9 if Y was 0. So we have one option. So this is my 0. Let me double check that. Yeah, this is my 0, 0, Y case. And then we'll look at our 1, Y case. Okay, so when Y was 0, that means I have only one option for Y. That means Z is 1 through 9. So 9 minus 1 is 8, plus 1 is 8. Got it. Okay, so then for my other condition, my other case, I should say, NYZ, I still have that 8 for N. And it said that if Y was 1, Z was only 2 through 9. Okay, so 9 minus 2 is 7, plus 1 is 8. 9 minus 2, yes, 9 minus 1 is 8. Oops, Miss Danny made a mistake. So for the 0 case, it's Z was 1 through 9, so 9 minus 1 is 8. 8 plus 1 is 9. So the first one, pardon my error, should be 9. There we go, that makes sense now. Okay, because that one I had options, what was it, 1 through 9, and then this one is 8 because it's 2 through 9. I had one option. So I'm going to multiply these, and I get 72 combos for my 0y case, and here I get 64 combos for my case where y is 1. So to figure out my total, well, that's not too bad now. I just got to add them up. 72 plus 64, okay, 70 plus 60 is 130. 4 plus 2 is 6. So I have 136 possible area codes. Nice. Not too many. According to the post-1995 rules, how many area codes are possible today? Okay. So let's see. The restriction was that y equals 0 or 1 was removed. Okay, awesome. So today, n is 2 through 9. Okay, very nice. The exception of the rules are codes of the form 37Z and 96Z. Okay, got it. Excellent, excellent. Okay, so then let's do that. Where y equals z. Okay, and the only other part, so area codes where y equals z are easily recognizable codes. Okay, well, we don't have to take care of that necessarily right now. Okay, so let's go ahead and do that. So going back to our post-1995 rules, okay, awesome. So I have still n, y, z. I still have, like I had before, 8 options for n. 2 to 9. Y is 0 to 8, so 8 minus 0 is 8, plus 1 is 9. So I have 9 options for y. And z I have 0 to 9, so 9 minus 0 is 9, plus 1 is 10. Okay. So that means 8 times 9 is 72, times 10 is 720. So that means I have 720 combos. But we need to subtract the exception, which said 37Z and 96Z. So 37Z and 96Z. Okay, so let's think about this. Z has 10 options. Okay, so there's 10 possibilities. So there are 10 possibilities to have this exception, this 3, 7, 10, right? Or 10 options. And then there's another 10 options or 10 possibilities for this outcome. So that means in total I have 20 possibilities that are off limit. I have 20 possibilities that are off limit. So that means I'm going to do 720 minus, here I have 20, minus 20 to get 700 possible area codes. Today. Okay, so the 7-digit numbers in a given area code have the form ABC-XXX, where X, B, and C can be any digit 0 to 9, and A is restricted to 2 to 9. There are two other restrictions. B and C cannot both be equal to 1 since these values are designated for other purposes like 911 and 411. And 555-0100 through 555-0199 are reserved for fictional uses such as in television shows or movies. How fascinating. According to these conditions, how many 7-digit numbers are possible in a single area code? Okay, so just like before then, I'm going to set up my options so I can figure out the total. So I have A, B, C dash X, X, X. Okay, so I know X, B, and C can be 0 to 9. So 9 minus 0 is 9, plus 1 is 10. So that means I can be 10, 10, 10, 10, 10, 10. Whoa, that's a lot of 10s. And it says A is restricted to 2 to 9. So 9 minus 2 is 7, plus 1 is 8. Okay, this is actually an easy math problem because I have 1, 2, 3, 4, 5, 6 zeros. So I have 8 million. These are area codes. Okay, and now we got to take care of those exceptions. So B and C cannot both equal 1. Okay, so that would tell me that if B is 1, that means I chose only one option, and C is 1, I chose only one option. I'm not writing 1 because they equal 1. That's not why. I'm writing 1 because it's suggesting that if B and C, B equals C equals 1. So that means there's only one option for this happening, times my other possibilities, which is X, 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 oops, not 10. Okay, so that's going to give me 8,000. So I know I'm going to be subtracting that. Okay. And then the other one is 550100 through 555-0199. So I have to figure out how many numbers are between these two, I guess, upper and lower ends. So that's pretty easy because 555 is the same. All I'm doing is subtracting 199 from 100. So 199 minus 100 is 99, and we can't forget to add 1 so we don't lose our first number out. So that's going to be 100 total. Okay, so then I'm subtracting another 100 here. So then this question becomes 8 million minus 8,000 minus 100. And we could do this in our head and get something like 7,900 and 19,000. 19,900. Because, 1, 2, 3, 4. I made a mistake. This should be 80,000. Hopefully you caught that. Because there should be 4 zeros. 1, 2, 3, 4. So it's good to double check your mental math. Shame on Miss Danny. So I was like, I know this is the right number, but not the right math. So 8 million minus 80,000, right? So if I subtract 80,000, I'm at 7,920,000. And so I subtract 100 from 920,000, and I should get 919,900. Cool. It's always good to box in your answer as well. Okay, so how many 10-digit numbers are possible in North America? Okay, well, we figured out how many area codes are possible. So there are 700 area codes. We figured out in question 3. And then in the last one, I should also be careful. Instead of us saying area codes, right, because this is not area codes we're talking about anymore. We're talking about specifically um, the numbers after my area code. So we'll just say digit numbers. You don't really have to include units here, but it's nice to figure out if we can so that it makes sense to us. So we figured out there was 700 from question 3, and then 7,919,900 digit numbers, I guess, from question 4. Multiply those out, and we should get a really big number. So we should get something like 5 billion? 543,930,000. Total 10 digits. So we should say these are 7-digit numbers. 10-digit numbers. Well, this is in North America. So I don't think we will run out anytime soon. And this will be considered an upper estimate because we're not including a lot of numbers that are reserved. So there's probably a little bit less than this amount. Not a whole lot, just a little bit. Great job. So that was a lot. Definitely review each part, make sure you got it. So some states are actually running out of license plate numbers. Delaware currently uses 6-digit numbers in its license plate numbering system. So now this is a little bit of an extension. We're moving away from telephone numbers and now talking about license plate numbers. Although recent reports show that its numbers are approaching 1 mil, Delaware uses retired numbers for new cars. In many cases, the state of Washington recently stated that it needs to explore options to its system of 3 numerical digits followed by 3 letters because it is running out of numbers. New Jersey changed its system of 3 letters followed by 2 numerical digits and 1 letter to a new system of 1 letter, 2 numerical digits and 3 letters. The last number under the old system was ZZZ, 99Z followed by A10AAA in the new system. So I would like for you to answer these questions and show me your math work in the Google form, or Microsoft form that I will post. I also just want to go back. I hope we understand the reason I talked about permutations in the end. We're still approaching, like the way we approached all the problems we just did, yes, we're like combinations, but if we were actually labeling telephone numbers, right, they'd technically be permutations. And why is that? Because let's think about in Dallas. Dallas, there's an area code of 214. That's different, right? Than 412. It definitely is. If I call 412, I'm definitely not going to be calling someone in Dallas. So, you know how we were saying, like, the lock for your locker is technically a permutation. So they should ask what's your permutation code. Well, telephone numbers, it's also what's your permutation number, not necessarily the combination of numbers because um, they'd be different. Here, order matters. Order matters. But we're approaching it just like the fundamental counting principle. That's really important to remember, right? Because let's say if they were just strictly combinations as we were doing in the beginning with clothes, we would definitely have a lot less options. So adding order to our numbers actually gives us a lot more options. Because let's think about it. 214, there are 214, 412, 124, 124. You could put so many of those um, in a group, and they would count as one if you were thinking about them like combinations instead of permutations. Awesome. I hope you enjoyed today. Good luck.